this is my experiment 2, the 1-bit ALU. Switch 0 corresponds to the first selector. Switch 1 corresponds to the second selector. Key 3 is input A. Key 2 is input B. Key 1 is my carry in. The first LED here is my carry out. The second LED is my Y. I use inverters on each push button so that when I press it, it is high, and when it is released, it is low. So all the inputs I will be doing, all the combinations, correspond to my pre-lab, where I give the waveform of the 1-bit ALU. So I will test out all the combinations right now. So when both switches are low, with both selectors are low, and they're all unpressed, the Y is 1. When A is low, or when A is high, still 1. When B is high, still 1. When A and B are both high, Y is 0. There's a carryout value. And then when A is pressed and the C in is pressed, there is both a Y and a carryout. When B is pressed and the carry in is pressed, there is a carryout and Y is 1. And when carryout is just pressed, Y is still 1. And when I press all three, there Y is 0 and the carryout is 1. When I put one of the selectors to high, try out the combinations, Y is now 0, Y is now 0, press both, Y is still 0, there's a carryout value. I press the carry in and A, Y is 0, carryout is 1, Y is 0, carryout is 1. When I press B into carryout, I press all three, Y is 0, carryout is 1. Same thing for switch 1 is on, so the second selector. All three. And when both are high. And if I choose, when at random, I've already tested it, I can choose A is high, B is low, carry in is low, and both of the switches are high. I should get no LEDs on, so both carry out and Y should be 0. Let's test that out, and that is true. So my 1-bit ALU has been successfully implemented onto my board.